take you through end-to-end approach for the post-install anchors. So a brief agenda. So how do we look into the overall scenario in this industry where these kind of technologies are utilized to, for the retrofitting purposes, or maybe for the other purposes where such kind of solution offering plays a very great role. So let's first try to understand what are the connection types. So as what we understand in a building, there are three kinds of connection. So first is a load bearing connection. If you see through this image also, you can see a steel building framework under construction. Why we term them as a load bearing connections is because these connections are majorly utilized to bear the load of the building. Then there are load transferring connections, majorly those connections which give load to the building structures. Few applications that you can see on the screen are like excavations with horizontal struts. You can see temporary street props under beams, which is utilized to provide support to the beam structures. Then you can see crane base plates anchored on these job sites for transferring the material from the ground level to the higher floors of the building. So now let's speak a little about the selection criteria for the right designing methods. So as per that, there are two kind of methodologies which are followed. So the first methodology, which is internationally accepted, is EC2 Part 4. So EC2 Part 4 gives a detailed, coder requirement about the parameters, the design calculations, the formulas that has to be utilized, and the complete design methodology, which is developed by EC2 Part 4, which gives us a detailed calculation and also gives us the right insight about the anchor loading parameters. Parallel to this, a new introduction in the market is IS 1946 2025. This is very recently introduced in the market. So Bureau of Indian Standards have recently launched about this code standards, which speaks about the detailed calculation for post-install both chemicals and mechanical anchors. As all we understand that on a base plate, there are two kind of forces that comes. The first is a tensile force and the other one is a shear force. Now, when you look into the scenarios and when we do the design calculation, basically we do the testing for the tensile force on the four parameters. We see if an anchor fails in steel, or if an anchor fails in pull-out, or if an anchor fails in concrete cone. And the last failure parameter which happens in the tensile force is concrete splitting. So a little brief about all of these failure modes. Steel failure is very well understood by the terminologies. The steel of the anchor can fail. The concrete doesn't fail in this scenario. Basically the anchor material fails. Okay. Then the second method, the second failure mode is the pull-out failure mode. In this, the base material remains intact, but the anchor slip out of the base material. Then comes the concrete cone, as all of us understand. बचपन में हम लोगों ने गमले में से कभी पौधा बाहर खींचा होगा, तो जड़ के साथ में you see soil attached to it in a triangular form or a conical form, right? So this is basically called as concrete cone failure. This is a failure in the base material. Then comes the last failure mode, which is concrete splitting. So the concrete splitting actually happens when you place two anchors very close to each other, or there is a failure mode in concrete. So now let's move towards the second failure mode, which is towards the shear. So again, in shear, then we have three kind of failure modes, depending upon the force which is going to come on the connection. So anchor can fail in steel by itself, as in form of terminology. If an anchor is placed very close to the edge distances, then the anchor can fail in concrete edge failure. And the pry-out failure is when a shear force comes and acts on the anchor, it takes out the base material from the one side. So if you place two anchors very close to each other, what you can see, the concrete cone of two anchors is going to overlap. So in this scenario, basically what actually happens is the concrete is being sheared in two anchors. So the ideal scenario is that the anchor is able to utilize the complete concrete cone. So in this kind of situation, anchor basically reduces, the anchor loading resistance reduces. Likewise, if you place an anchor very close to edge distance, then again, this is a similar kind of a scenario where anchor is not in the complete cone formation, because there's the lesser base material available for the anchor to utilize the complete design resistance of itself. Then if you place anchors in very thin slabs, so basically the ideal scenario is that we design the connection in a manner that we have the ideal spacing. and we utilize the right designing parameters as per these job site conditions to get the right selection and the optimized embedment depths and the different other parameters to it. There are also test reports available in the market. So basically, there are third-party test reports which evaluates the performance of anchor. So these third-party test report, which is majorly followed in the market, are the ETA certificates. So basically, we also need to understand that how the product performs and have we tested such kind of parameters. So basically, all the testing cannot happen actually in the real world scenario. This is why we have to simulate these conditions in a lab, and these lab produce a document which we call as an ETA document. Likewise, we also need to check the topic which is regarding to the seismic conditions. As you understand that different places in India falls in different seismic zones. Likewise, different places in India have different humidity conditions. So if we are in a dry atmosphere, maybe you may not require a stainless steel anchor, but if you are in a humid climate, then you have a requirement to proceed ahead with a stainless steel anchor because of a better life. Parallel to this, if you falls in areas like Delhi, areas which is towards the north in India, which is typically zone 5 or higher. So in such kind of conditions, you have to by default have to make an anchor selection which can qualify the seismic parameters and can withstand the seismic forces. Parallel to this, then we also look into the environment compatibility. So we need to select anchor which provides the highest corrosive resistance, highest performance on the high temperatures, and then comes the last parameters depending upon the installation processes. Like in very thin thickness of concrete, basically we try to proceed ahead anchors which will not damage the concrete surface. So likewise, there are these parameters which has to be considered by ensuring the maximum safety and parallel to make the right connections. What we have been speaking that why design becomes such an important case, because these are the applications which is critically utilized to withstand the loads. Okay, so if there's any mistake being done in all of these three parameters while the selection of anchor, while the designing of the anchor, and parallel to this also towards the installation of the anchor, then this can lead to a very critical failure which can even cause damage to both life and assets. So nowadays, what actually happens is that there are a lot of parameters on which you have to check, and you can do these calculations both manually and also through a software. So what we utilize in the overall industry is to ensure that the anchor perform as per the design forces, and we get the right status that these anchors are going to withstand the forces which is going to come on them. So towards that, there are certain failure modes that has to be checked. Like what we have spoken earlier towards the tension load parameters, you can see different kind of loading parameters which was coming on the anchor, looking towards the overall capacity of the anchor and also seeing the utilization percentage. So this gives me a clear indication if my anchor is safe or not. Parallel to this, again, there's a combination. There's a check for shear loads. Likewise, what we have discussed earlier, then the shear loads parameters are also tested. And there's a third kind of parameter which we have to also test is a combination of both tension and shear. All the anchor should qualify in all of these three parameters. If the anchor doesn't qualify in all of these three parameters, then we cannot utilize this anchor to be actually recommended for the job site conditions, and we cannot do the installation on the job site. This slide gives a clear indication about the installation processes. As what you can see through this image on the right hand side, if a force is going to come on this subject, then there will be tendency that the upper anchor will go in tension and the lower anchor will go in compression. So towards that, if I'm utilizing a mechanical anchor, so you can also see this in the picture. Mechanical expansion anchors only functions when the torque is rightly performed on the anchor while the installation processes. If I'm going to under torque it, then my sleeves will not expand, and this means the sleeve will not come in touch with the base material, and hence so the anchor will not be able to withstand the design forces. So you can also see on the left hand side that if the anchor is installed correctly, the anchor load bearing capacity is way higher. If the anchor is not torqued properly, it is under torqued, so this means this sleeve will not perform, and this may lead to a failure. Parallel to this, if you even over torque an anchor, this over torquing may create splitting in the concrete, and which may not allow the complete design resistance of the anchor to come in place. So again, when we look into the scenario for the installation processes, we should follow the right designing methodologies, and we should also follow the right installation processes as provided by different manufacturers which are there in the market. So while understanding all this scenario, we can clearly understand that all these parameters are equally important, and if I miss any one of these three from the qualification, designing to the installation, this is what can happen on your job site. As you may have heard about a few news in the industry that certain structures fell down. So majorly, this kind of failure can happen on in any of these three parameters. It may happen in the selection of the anchor, it may happen in the designing of the anchor, or it may happen while at the installation of the anchors. So if we do not take the right methodologies in place, we do not follow the right practices in place, then you can clearly see what can be the damages that can happen. So you can see an image on the left hand side where a canopy has fallen down. The reason can be many. Likewise, this is how a representation of how a concrete cone failure happens. And on the right hand side, you can see an ISMB member uh, toppled on the right hand side and taking the concrete out and the anchors banding. So at last, what we do and provide as in services. So Drew, as in service, what we do, we provide strategic design guidance. Since every case is unique, so for every unique case, there has to be proper parameters to be considered, which should be code compliant, should be safe, and should be efficient, ensuring the right loads and capacities of the anchor. Parallel to this, we also consider different application-based solutions. So like if you have a heavy weight application, then the solution should be tailored made as per the requirement of the application. It should not be a common practice that we follow a common practice of this anchor I have utilized in my last project. So I think this similar anchor will work in this project as well. This is not the actual case scenario. This is somehow where layman people speaks. When we speaks about being a designers in the market, we have to ensure that the solutions are prepared as per the right application methodologies. Then towards this doesn't just complete here while they're designing. There are different technical documentation and codal compliances which comes in place. So while this complete practice, there should be proper design reports, there should be submittals, there should be proper documentations, there should be the right submissions for the selection of products, there should be product data sheets, there should be approvals from different authorities, and this is how this complete compiling and documentations happens on a particular project. And at last, there should be on-site support. People should be there to evaluate the performance of the anchor. This should happen both pre-installation, while during the installation, and after the installation as well. Because on different job sites, the parameters are different. At some places, a rebar may come while installation of the anchor. At certain places, we may find that the drawings have been appearing a little different what is than the actual case scenario on the job site. And this is how this overall evaluations comes in place. So this is it from my end. I think you had a wonderful session.